Yeah, this is the magnified picture of the main scale. So here you can see the numbers 1, 2, 3. They are not the centimeters, they are the millimeters. The 10 parts are the 10 divisions inside 1 centimeter. The first centimeter. So this is the 1 centimeter part. Okay, just to understand more clearly, I have taken magnified picture of 1 centimeter. So there are 10 divisions. So here I have given the numbers 1, 2, 3 up to 9. So these numbers, they indicate the millimeter divisions. Now the second part, that is the Vernier scale that slides over the main scale, is shown. So here you can see again there are total 10 divisions on the Vernier scale. Now each division on the main scale, that is equal to 1 millimeter. First division is coinciding and the last division is coinciding exactly. You can see here. So the 10th division is exactly coinciding with the 9th division. So here 10 Vernier scale divisions are exactly coinciding with 9 main scale divisions. So therefore this 9 main scale divisions can be written as 10 minus 1. Okay, 10 minus 1 main scale divisions. So in that case, if you take capital N as a number of Vernier scale divisions, so that is, instead of 10, if you write n Vernier scale division, that will be equal to n minus 1 main scale division, because 10 Vernier scale divisions is equal to 9 main scale divisions. So therefore, in general terms, we can write n Vernier scale divisions is equal to n minus 1 main scale divisions. And this is the principle of the Vernier calipers. Here we know that the 1 main scale division is 1 millimeter. Therefore 10 Vernier scale divisions will be how much? 10 Vernier scale division, that is the length of the Vernier scale we say. You just also remember, 10 Vernier scale division means the length of the Vernier scale, that is equal to the 9 divisions on the main scale, and each division is of 1 mm. Therefore 9 into 1 mm, it will be 9 millimeters. Therefore the length of the Vernier scale is 9 millimeters, and from this you can find what is the length of 1 Vernier scale division. What is the length of 1 Vernier scale division? That is equal to 1 Vernier scale division is equal to 9 by 10 millimeter, that is 0.9 mm. So here if you just observe carefully, the first division is little small when compared to the first division on the main scale. Now if you calculate the length, it is 0.1 mm less. Okay, if the one division on the main scale is 1 millimeter, then the first division on the Vernier scale is 0.1 millimeter less. Therefore it is how much? 0.9 mm. Now here the difference between these two divisions, that is one main scale division and one Vernier scale division, that is equal to 1 mm minus 0.9 mm, that is 0.1 mm. Okay, this difference is the least count of the instrument. Here initially the 0th lines on the main scale and the Vernier scale both are coinciding. Now when I just open the scale such that the first division on the, or the first line on the Vernier scale is exactly coinciding with the first line or the first division on the main scale, that is the first line is coinciding with the first line. Look at the scale carefully. So whatever the difference that you see, that is 0.1 mm, now it is created between the two zeros. So in the case of a Vernier calipers, we are taking the measurement, means we always find the distance between the two zero lines. One zero line is the zero line on the main scale, the other one is the zero line on the Vernier scale. So here whatever the gap that is created between the two jaws, that is equal to the 0.1 mm, that is equal to the gap between the two zero lines. Therefore this is the least measurement that can be taken by using Vernier calipers. Therefore this is the least count of the Vernier calipers, and this gap between the two jaws is equal to the difference between the two division, that is one main scale division and the one Vernier scale division. And we calculate, how do we calculate? And this gap is equal to, here the first divisions are coinciding and the gap that is created is 0.1 mm. Therefore if you insert a sheet which is having a thickness of 0.1 mm, that can be calculated by using the Vernier calipers. Vernier coinciding division here is 1, and the least count already we have calculated, that is 0.1 mm. okay, the total reading will be the least count into the Vernier coinciding division, that is 0.1 mm. Okay, now if we open further such that the second division is coinciding, or the second line is coinciding with exactly with the second line. Okay, therefore the Vernier coinciding division is 2 and the least count is 0.1 mm. Therefore, okay, the reading or the gap between the two jaws, that is equal to 2 into 0.1, that is 0.2 mm. So here the gap between the two zeros, okay, this one, okay, two zeros will be 0.2 mm. So therefore the distance between the two jaws will be 0.2 mm. So same thing will be happening. So when the third division is coinciding, the Vernier coinciding division will be 3 and then the least count is 0.1. Therefore the gap between the two zero lines will be 0.3 mm. That is the gap between the two jaws. Similarly, okay, for the fourth division, when they are coinciding with each other, so you get the distance between the two zero lines, that is 0.4 mm. And then for the fifth one is 0.5 mm. So here normally if you take a normal centimeter scale, a normal scale, so in that case we know that, okay, 1 mm the length of the smallest division. Okay, now that smallest division, okay, we have divided into 10 parts by using, okay, a sliding scale, okay, on the main scale, and that too in a very simple manner. When the 10th division on the Vernier scale is coinciding with the last line, that is 1 centimeter line, the zero line is coinciding with the first line on the main scale. Now whatever the distance between the two zeros you find here, okay, that is the gap between the two jaws, that is 1 mm. Now it is crossing 1 mm line. So here we know this one, this distance, okay, 0 to 1, that is 1 mm. Now we need to calculate the remaining distance, that is the 1 to 0, gap between the two red lines that is shown on the screen. So here this is 1 mm. Again we need to take the coinciding division, okay, that is Vernier coinciding division, that is first one, okay, n is equal to 1 and the least count is 0.1. The reading we take on the main scale, that is called main scale reading, that is 1 mm, and to which we need to add the distance between the two red lines, that can be calculated from the formula n into LC. So therefore the total reading or the total gap between the two jaws, that is the gap between the two zero lines, that is equal to main scale reading plus Vernier coinciding division into least count. So that gives 1.1 mm. I hope you have got the clear idea.